Hello students, welcome back to your own channel Framing the Techminds. Today we are going to revise chapter 4 Carbon and its compound from class 10 science in a very detailed, easy to understand and exam oriented way. In this video you will find such wonderful clues which will clear your all doubts and will benefit you in your board exams. By the end of this video, you will understand every topic clearly: carbon properties, covalent bonding, homologous series, functional groups, nomenclature, reactions, ethanol, ethanoic acid, soaps and detergents. So let's begin this quick and complete revision. Number 1. Why carbon is a special element? Carbon is the backbone of all life on earth. Every living thing, plants, animals, humans, is made of carbon compounds. But why is carbon so special? Carbon shows two very important properties. Tetravalency. Carbon has 4 electrons in its outermost shell. To become stable, carbon needs 8 electrons. These are 3 possible ways to do that: lose 4 electrons, gain 4 electrons, share 4 electrons. But losing or gaining 4 electrons need a lot of energy. So carbon chooses the easiest way, sharing electrons. Thus, carbon always forms 4 covalent bonds. Example, CH4, methane. Carbon shares 1 electron each with 4 hydrogen atoms. Catenation. Catenation means self-linking ability. Carbon atoms can join with other carbon atoms to form long straight chains, branched chains, ring structures. Carbon is the only element that shows catenation to such a large extent. For example, glucose, proteins, plastic, DNA, petrol, oils all are carbon based. Because of tetravalency and catenation, carbon forms more than 10 million compounds. That's why carbon is called versatile element. Number 2. Covalent bonding. Covalent bonding is a type of chemical bonding in which two atoms share pair of electrons to become stable. Instead of gaining or losing electrons, the atoms share them. Most carbon compounds form covalent bonds. In short, electrons are shared, no ions are formed, no positive no or negative charge is created. Properties of covalent compounds: low melting and boiling point because forces between molecules are weak. Do not conduct electricity because there are no ions or free electrons. Usually liquids or gases. Only a few solid compounds exist. Examples: H2 single bond, O2 double bond, N2 triple bond, CH4 methane, CO2 carbon dioxide, CCl4 carbon tetrachloride. Number 3. Allotropes of carbon. The element carbon occurs in different forms in nature with widely varying physical properties. Allotropes are different physical form of same element. Carbon has 3 important allotropes. First, diamond. Each carbon is bonded to 4 other carbon atoms. Tetrahedral arrangement forms a 3D network. Hardest natural substance. Does not conduct electricity. Very high melting point. Used in cutting tools, jewelry. Second, graphite. Carbon atoms arranged in layers. Each carbon bonded to only 3 atoms. One electron is free, conducts electricity, soft and slippery, used in pencil lead, lubricants, electrodes. Third, fullerene C60. Looks like a football. 60 carbon atoms arranged in a sphere, a new discovery in carbon chemistry. Now some exam questions for you to think. Why diamond is hard? Why graphite conducts electricity? What is Buckminster fullerene? First answer, diamond is hard because each carbon atom is strongly bonded to 4 other carbon atoms in a tetrahedral arrangement, forming a 3-dimensional rigid network. This continuous network of strong carbon-carbon covalent bonds makes diamond the hardest natural substance. Next, why graphite conducts electricity? Graphite conducts electricity because each carbon atom in graphite is bonded to only three other carbon atoms, which leaves one free electron per carbon atom. These free electrons move freely between the layers of graphite and carry electric current. Last answer. What is Buckminster fullerene? Buckminster fullerene C60 is an allotrope of carbon in which 60 carbon atoms are arranged in the shape of football, soccer ball. 4. Saturated and unsaturated compounds. Saturated compounds. Alkanes. Only single bonds. General formula CnH2n plus 2. Example methane CH4, ethane C2H6, propane C3H8. Unsaturated compounds. Alkenes and alkynes. Alkenes double bond. General formula CnH2n. Example ethane C2H4. Alkynes triple bond. General formula CnH2n-2. Example ethyne C2H2. Unsaturated compounds are more reactive because double or triple bonds open up easily. Number 5. Carbon chains. Straight branched ring. Carbon compounds can form different types of structures. Straight chains, example butane. Branched chains, example isobutane. Ring structures, example cyclohexane C6H12, benzene C6H6. Benzene is a very important because it is found in detergents, dyes, perfumes and plastics. Number 6. Functional groups. Functional groups are special atoms or groups that give unique property to compounds. Important functional groups: alcohol, aldehyde, ketone, carboxylic acid. Functional groups decide smell, reactivity, acidity, naming. These are frequently asked in exam. Number 7. Homologous series. A homologous series is a family of compounds that have same functional group, same general formula. Successive compounds differ by CH2, similar chemical properties, gradually increasing physical properties. Example alcohol series: CH3OH methanol, C2H5OH ethanol, C3H7OH propanol. Each next member differ by minus CH2 4 AMU. Number 8. Nomenclature of carbon compounds. Let's learn how to name carbon compounds by step. Step 1. Count the carbon atoms. Root word: 1 meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hep, 8 oct, 9 non, 10 dec. Step 2. Check the type of bond: single, ane, double, ene, triple, ine. Example C2H4 ethane double bond, C3H4 propyne triple bond. Step 3. Identify the functional group: alcohol OL, aldehyde Al, acid OIC, ketone on. Example CH3CH2OH ethanol, CH3COCH3 propanone. Step 4. Numbering the chain. Start numbering from the side where the functional group of double bond gets smallest number. For example, CH2 CH CH3 prop 1 ene mean prop 1 ene is an alkene where 3 carbon atoms and a double bond on the first carbon. Not prop 2 ene. Incorrect. This is a high scoring topic and questions always come from naming. Number 9. Important reactions of carbon compounds. Combustion. Carbon compounds burn in oxygen to give heat. CO2 plus H2O heat. Example, CH4 plus O2 gives CO2 plus H2O. This is why fuels like petrol, LPG and CNG release heat. Oxidation. Oxidizing agents like KMnO4 or K2Cr2O7 add oxygen. Example, ethanol gives ethanoic acid. This is asked in exams many times. Addition reaction happens only in unsaturated compounds. Example, ethane plus H2 gives ethane. Nickel catalyst. Substitution reaction happens only in saturated compounds. Example, CH4 plus Cl2 gives CH3Cl plus HCl in presence of sunlight. Very important for MCQs. Number 10. Ethanol. Ethanol is a colorless liquid used in medicines, perfumes and hand sanitizers. Important properties: soluble in water, volatile, burns with a clean flame. Important reactions with sodium. Ethanol plus Na gives sodium ethoxide plus hydrogen gas. Dehydration. Ethanol gives ethane plus water using concentrated H2SO4. Oxidation. Ethanol gives ethanoic acid. Number 11. Ethanoic acid. Acetic acid. Ethanoic acid is found in vinegar 5 to 8% solution. Reactions. Number 1. Esterification. Esterification is the chemical reaction in which a carboxylic acid reacts with an alcohol to form an ester and water. This reaction usually occurs in the presence of concentrated acid catalyst such as concentrated H2SO4. Alcohol plus acid gives ester plus water. Esters smell fruity. Second, with bases. CH3COOH plus NaOH gives sodium acetate plus water. Third, with carbonates. CH3COOH plus NaHCO3 gives CO2 plus water plus salt. Effervescence. Number 12. Soaps and detergents. Soaps work in soft water but not in hard water. The molecules of soap are sodium or potassium salts of long chain carboxylic acids. Soap molecules form micelles. The hydrophobic tail traps oil. The hydrophilic head mixes with water. This helps in cleaning. But in hard water, soap forms scum, so detergents are used. Detergents work in both hard and soft water. Detergents are sodium salts of sulfonic acids or ammonium salts with chlorides or bromides ions, etc. And this completes the most detailed explanation of carbon and its compounds. If this video helped you, please like, share and subscribe for more such useful revision lessons. All the best for your class 10 board exams. Thanks for watching.